All right, so let's take a look at the next couple OT chapters in this simple book, short and simple, and then I'll talk about the next project. So, you, this is the thing that's leading to all the security problems, is combining operational technology with information technology, so you're connecting your devices on the internet. Um, Now, the reason everybody's doing it is because it has business advantages that outweigh the security concerns. So you can now display your sensor on bulletin boards, you send alerts, this is, and so you have this situation, and also you can connect to them remotely. And so, therefore, you can monitor your vehicles with GPS, you can include real-time data about the price of things you're buying, and adjust your production. You can take many sensors and scan them for unusual activity, so maybe you can better detect malfunctions and things wearing out. You're able to use all the powerful IT information gathering and processing systems to make more intelligent decisions about your operational technology. That's the idea. And of course, there are the challenges. The main one probably is this human challenge. Your OT team has a traditional way of doing things. They're thinking like factory workers. They're not thinking about the internet and cyber attacks. They're thinking about reliability and handling the extreme conditions and maintenance of the devices and keeping them up 24/7 for things like water plants and power plants. And they just have a whole different set of priorities and culture and ideas than the IT team that has all the traditional worries about viruses and exposed network ports and constantly updating and changing things. And so that's the fundamental problem here, is a huge clash between these two cultures. And therefore, the OT systems use old technology because they're supposed to build something like a water plant that's just supposed to stay the same and keep working the same for 20 years, whereas in IT, you have to put on patches every month and change the whole operating system every couple of years, and that's a completely different philosophy. And that's the problem. One solution is middleware, to try to have some kind of device in the middle to connect your IT systems to your OT systems, which might make the connection, but it doesn't really solve the fundamental problem that the OT stuff is fundamentally extremely out of date and vulnerable, and you really can't change that fact. So your IT threats like malware can then affect the OT, which is what we're going to do in the projects. And you have to add defenses. The classic old defense was an air gap. Your OT system was simply not connected to the internet at all, but now that is not acceptable from a business efficiency point of view. So we have to have things like VPN concentrators and firewalls and IDS and access control to try to limit the connection to the internet. And therefore you need awareness and incident response plans to deal with the cyber incidents that are going to occur. Now, the OT devices can produce a lot of data, so you might overrun your log analysis system, and then you'll have to implement big data techniques like data analytics and machine learning, like the one I was just mentioning in the news, where they have all the data from all your workers' chat, so they use AI to try to filter that stuff out. So, and then of course there's regulatory compliance. There are rules about occupational safety, environmental sustainability on the OT side, and then there are rules on the IT side about things like data privacy. So you've also got a compliance issue where two different compliance teams with different concepts of what they're doing have to somehow work together. So let's look at a Kahoot about that stuff. I've got them ready. Here we go. All right. There we go. All right. right? All right, anyway, I'm distracted by trying to fix up my Debian 12 system, which is not working very well. Anyway, let's go ahead here. All right. All right, so which one of these comes from the attitudes of people? All right, that's cultural differences, of course. All right, which benefit comes from avoiding waste? Yep, that's efficiency. All right, and which one comes from laws? All right, that's regulatory compliance. All right. All right. So let's take a look at the next bit. All right, so we'll talk about the architecture of the OT system. So you got a lot of components. You got hardware, you got the actual industrial machinery, the heavy equipment and motors and such. And then you got the control systems like programmable logic controllers, distributed control systems, and SCADA, supervisory control and data acquisition systems, which typically look over a group of PLCs. And then, of course, above that, you got the traditional IT stuff with switches, routers, and firewalls. And under this, at the bottom, you have endpoints like sensors and actuators, which are turning motors on and off and detecting things like temperature and pressure. You got software all over the place. There's human-machine interface applications, which are things that let humans control the equipment. There are data historians, they call it, things recording logs and such, and predictive maintenance tools, trying to detect when things are wearing out. And you got all the networking stuff we've talked about. Now, this is all standard IT stuff except for Fieldbus. Fieldbus is the industrial digital communications network, and this includes Modbus and Profibus. DNP3, for some reason, is not included on this. The two most popular OT protocols I read about are Modbus, by far the most popular, and DNP3, which is popular in electrical utilities, a more modern one. All right, so control systems we talked about, and there are interfaces, which are places where users or other systems interact with OT systems. So the human-machine interface are where operators monitor and control processes, and then there are APIs, as we know, where software applications interact, where one software system can talk to another. So all Windows applications run, and then they use the Windows API to call the kernel to do things to the hardware, and so on. And those are the gateways between one system and another. All right. So there's centralized architecture. You have a central system like SCADA or PLC, and this will manage the connected OT devices, usually in one factory or something. And that's simple. That's the way it typically works, but it does mean you have a single point of failure if there's just one SCADA or one PLC controlling things. Distributed architecture is an alternative way to do it, of course, where you have a distribution of systems among several systems, and that, therefore, is more resilient. As some of them fail, the others can, in principle, take over, but it's more complicated to manage. All right. You can have a hierarchical system where you have layers of control, the sensors and actuators at the bottom, then PLCs, then SCADA above them, and then enterprise IT above them. And that's typically what you have. All Right, you can have multiple systems connected to a network, which makes it a lot easier to gather all the data in one place for improved efficiency and predictive maintenance and so on. But then you've got to consider your network reliability and security. Since you're connecting a lot of things together, you're expanding the attack surface. And there's hybrid architectures that combine these. All right, and for the OT systems, like I say, the main thing you want is reliability and availability. You want to use off-the-shelf components that are easy to replace, and you want to keep it reliable with redundancy and fault tolerance and backup systems so that your plant can keep running even as the components fail. You want to anticipate future growth and have modular architectures as things are constantly changing. And it'd be nice to have some way to integrate new features without disrupting the ongoing operations. Same thing's true of IT systems, although it's considered less of an extreme problem to take them down for maintenance. Interoperability is good, using standard interfaces and protocols. And safety and security. Safety here typically meaning physical safety of the humans that might get harmed when the equipment malfunctions and causes explosions and sparks to fly around and such. Fail-safe operation, compliance with industry standards and regulations, and then the cybersecurity controls, all the stuff we talk about, access control and encryption and network segmentation. So you have to have intuitive user interfaces for the human factors, clear and actionable information, ergonomics, so your workers are not having to bend over in uncomfortable positions and hurt their backs and such, and including user feedback. And then, of course, the business side. How much does all this cost, and what's the total cost, and what's the return on investment? So here's some best practices. When designing your OT system, you engage with your stakeholders and delineate your objectives, your performance standards, your regulatory operations and safety prerequisites. You have to balance all these things and use a modular design with standard interfaces so you can use off-the-shelf equipment and easily replace it, find people that are trained to use it and all that, the reason why standards are important at every level. And you make a resilient network infrastructure. Use segmentation to isolate the critical parts so flaws won't spread so easily into them. Secure your remote access points and regulate your access controls to try to prevent external attackers from getting in. And then the traditional cybersecurity with firewalls and IDS, access controls, updates, and patching on the IT side. You got data analytics, so you have the same issues. Whatever data you collect, you have to have backup mechanisms, retention policies, and things like data governance policies. How are you going to handle that data and protect it? And how are you going to use that data and analyze it in some way to extract useful information? And you educate your people and have documentation so they understand how to operate and maintain the OT system and all the other documentation they need, like configurations and troubleshooting guides. You have to have a way to test your stuff, and both for functionality, performance, and security. And you have to have proactive maintenance and upgrades. This would be best to stay on top of the upgrade and repair cycle instead of just letting things break and go down and fixing them only when they go down. So audits and assessments are useful here just to keep things organized, to achieve a higher maturity level of performance. All right, let's take a look at another Kahoot, which is here. All right, I think that's it. What are the points where users interact with the OT? Yeah, those are called human-machine interfaces. All right, where do you get a single point of failure? Yep, obviously a centralized system. You have this one central device. If it fails, you no longer have connectivity. All right, and which practice includes segmentation? All right, that's a way to make your network infrastructure resilient. Okay. All right. All right. Stop this recording if I can figure out where my control system has gone. There it is. All right.